Good afternoon, good morning, good evening, wherever you are. Thank you very much for joining this TDL webinar. We've got a very exciting panel looking at a very hot topic, confidential computing in 2026. This session will last an hour. It will be recorded and made available. The recording will be made available on the TDL channel on YouTube, as well as report on Substack. You're welcome to submit questions to the panel, which will be distributed by the moderator through the chat facility at any time. So with that, I'd like to hand over to our TDL strategic advisor and moderator for the afternoon, Claire Vishik, who will take things from here. Over to you, Claire.
Thank you very much, David, and thank you and thanks to TDL for hosting this important topic. This topic is certainly very dear to my heart. Many years ago, as a young student, before TCPA was even created, the first official meeting I had on research was dedicated to sort of the predecessor technology to trusted computing. Trusted computing then had a bumpy but very intense and important history, and then confidential computing appeared later based on the lessons learned and the technology development that we experienced since the ideas of confidential, of trusted computing first appeared in, I guess, the very late 1980s. It is great that we have an opportunity today with this distinguished panel to discuss the current state of confidential computing. What are the benefits? What is the current status of deployment in all areas? What are the killer applications? What are the challenges? What is the immediate future, including from the business point of view? What are the technical issues? All this we will try to squeeze into those 60 minutes. We are fortunate today to have a distinguished panel. I will very briefly introduce the panelists, but you can read more about them online. We have Henk Bergholz, who is the principal architect at Fraunhofer SIT. We have Jan Kamenisch, who is distinguished researcher at Sub-Zero Labs. We have Greg Kasmirchuk, who is the principal investigator at Encrypt. Ian Oliver, who is a professor of practice at the University of Oulu. And finally, Ron Perez, who recently stepped down as Intel Fellow and Chief Security Architect at Intel. With that, and thanking the panel for joining us today, I will start with the first question, and that question is, what is your general view of the current status of confidential computing? What do you think is important? What do you think is crucial? And we'll go in the alphabetical order for this. Henk, would you please start?
Sure, thank you, Claire. That's a broad question, so let me try to be brief. You started with trusted computing, and in order to trust in a tester and to prove the trustworthiness and such, you have to do a little big dance. You need a lot of infrastructure out there. You need trust anchors, you need some endorsers, you need verifiers, you need infrastructure. So it's not cheap. So everything you have to maintain additionally costs money. And there was a limited amount of scenarios where the spending was warranted. So now, with the arising isolation principle that comes with the confidential computing concept, it's very important to understand that the platform that you're running your confidential workload in is exactly doing what you want it to keep confidential. So it can now use remote attestation to show the capabilities it has. So there's some transparency about the confidentiality here, and it's believable. That's really great. So this is giving trusted computing yet another boost, and that's great. But also isolation is a great feature, and it's also a little obstacle because it's confidential. Now you can't look inside a workload. And now it's really hard for a platform to do remote attestation about it. I mean, you can do it at the start, but later on, it's on its own. So now you have dealing with two entities here and not just one. And I guess that's an interesting hurdle. Everybody has their solution, and it is kind of converging. But that's where we are right now.
Thank you very much, Hank. What do you think about diversity of platforms that could use confidential computing today? Back in the day when the idea of trusted computing appeared, we had just, well, essentially one platform. That's how the whole paradigm was designed. What do you think is different now that we have literally thousands of different platforms needing the same attestation or similar attestation?
So platforms are vendor specific, I want to say, and even inside a vendor's portfolio, there are different confidential computing platform qualities, I want to say. So what actually is confidential? Is it everything on the bus? Is the memory encrypted? Is the database encrypted? So is the operation in the CPU encrypted? So all these are feature sets that are now really difficult to differentiate. So you must burden yourself with selecting the right platform. And also, you should not burden the poor relying party that in the end just wants to know that everything is okay. So that is called relying party empathy. Best case scenario, the same Boolean okay goes to the relying party when you migrate it from a VM to a confidential VM. This is just a spitball example, but don't burden the relying party with all these capability results, maybe, or potentially, even if it's possible, have them for the verifier and then through as a pass-through if desired. So I guess this heterogeneity is like with the evidence. There's a ton of evidence, but let's make it and keep it simple for the relying party that in the end just wants to work and fly by device, maybe.
Thank you very much. That's a very good view of what we have now in today's heterogeneous environment. Ian, what do you think about confidential computing, its place today, and where it's going?
Probably speaking from the European side at the moment, I mean, the biggest word that's going around here is sovereignty, and the ability to, compute, store your data, etc., in places that are potentially insecure. We've also got a lot of systems going out to insecure places. We're needing to do processing on there. There's features in 6G that's now being proposed for being able to distribute AI onto edge and far edge computing environments and so on. So there's a lot of need for this. My biggest concern, however, is availability of confidential computing, and not really in terms of do we have the CPUs that can do this? Do we have ARM, CCA, TTX, SEV, and so on? But rather the availability of the infrastructure around that. Who is, what's the infrastructure around the supply chain? What's the infrastructure at runtime? What's the place of the attestation server in this? I mean, we worked on the architecture of this quite a lot previously, and being able to test things is critical. But how you do that attesting, when you do the attesting, what information is coming out of that? How do you know what you're attesting? Where are these expected values coming from? And then ultimately, how do you start diagnosing a system that is deviating from this confidential or trusted ideal with areas such as digital forensics? I think this needs to be put together in a much more sane way, possibly. But also, I mean, this then comes back, I'm just making some notes here, is do we have canonical or standardized forms for attestation information, attestation interfaces? How are vendors going to express this is what you can attest against, this is what you need to check? You know, as a user of this, all I want to do is start my workload, point my attestation server at that and say, okay, is that good? And what I should come back ideally is a yes no answer, but that yet no answer has an awful lot of processing, a lot of information in front of that to get to that point. So that's going to be our main challenge, is how to simplify all that infrastructure around there.
Thank you, Ian. What you are talking about, the complexity of attestation from several points of view, has always been the top issue in all the surveys that have been circulated on this subject. What do you think can be done to simplify attestation? Does it need to be simplified as a process, or can we simply make it faster and more seamless through applications? What needs to be done?
I think we need a good look at the process of doing this. So me as a developer, okay, I want to produce something, but in order to be able to run that in a confidential computing environment, I need to know about signing. I need to know about how to measure that. Software bill of materials, hardware bill of materials, and so on. So there's a lot of work that needs to be done there. That's a very, very complex process for somebody who just wants to deliver something. Integrating that into the processes, I mean, Salsa has been trying to do that through GitHub and so on. The availability of attestation. We've got tools from Red Hat, Google, Facebook are using this as well. Intel, of course. I have my own attestation server, and I've seen quite a few very much ad hoc systems pop up now in discussions. So there is a danger that we're going down this route, that in order to make it simple, everyone's going to come up with their own ad hoc solution to this. And I'm really not 100% clear on how we're going to, well, I think I know that we have to address it. I just don't know how we're going to do it. But maybe sometimes we as developers of this technology should go and use it in the real world, just to see how complex we've accidentally made it, possibly.
An excellent point. And actually, number two challenge for confidential computing is usually the lack of combined skills necessary to implement attestation. This is something that you briefly addressed. We have examples of excellent ideas that were too complex to implement in real life. Direct anonymous attestation, for instance. In trusted computing is one example of this. Works great in the lab, doesn't work great in real life. Thank you very much. We will return to this topic. For now, Greg, what do you think about confidential computing in March of 2026?
Thank you, Claire. As you mentioned earlier, Claire, there have been some notable confidential computing precursors that attempted to solve the same problem with varying degrees of success. There was IBM's Abyss architecture. There was the IBM 4758 crypto processor. My old company had an embassy device and infrastructure, and even ARM's Trust Zone, began shipping around 2006. But confidential computing is kind of now broadly available from a number of hardware vendors: Intel, AMD, ARM, NVIDIA, and it's increasingly integrated to cloud platforms. The most important areas of development, I think, today are regulated cloud workloads, sovereign infrastructure, I think that was mentioned earlier, healthcare data processing, and increasingly so AI model hosting. I think these sectors face elevated concerns above insider risk, above hypervisor compromise, and multi-tenant exposure. The major achievements, I think, over the past few years include the transition from enclave-based systems to full virtual machine-based level memory encryption, hardware-backed remote attestation at scale and confidential GPU enablement. So there have been quite a few advancements, just within the last several years, combined with consortium and standardization efforts and open source ecosystems. This has moved confidential computing from research and niche deployments into production cloud offerings, and that's very encouraging. But there are, challenges still remain. There's fragmented attestation, kind of discussed already, operational complexity, performance overhead. Those are just a few of the challenges. I think we're likely to see confidential computing become more available, but never become universally kind of the universal compute. Its adoption is increasing for high value, high sensitivity workloads, primarily for AI and regulated sectors.
Thank you very much. I would like to drill down on something you mentioned. There are different ways to implement confidential computing. Several large companies, well, Google, Intel, have their own approaches to what they do to create confidential computing environment. Do you think it's good, or do you think we need to attempt to create something that is shared by everyone?
All beneficial technology is good, but as Ian mentioned, right, having a common infrastructure working across devices that allow implementers to leverage technology for multiple vendors and not be locked in is crucial. Having interoperability to allow implementations to work with multiple vendors, multiple infrastructures, multiple services is critical. While specific implementations may offer incredible capabilities and benefits, without having a common set of services, common set of interfaces, and easy to use systems, we're just going to be having a difficult time moving forward. I think most of us on this panel have seen how difficult it's been to implement attestation services. My old company first created an attestation server in the early 2000s, it's over 20 years ago, and they're financially not viable, but in and of themselves, right? They're an accompanying service. There's not a business by themselves, or at least not yet. So without having some interoperability for all these services combined, it's going to be difficult to actually move the state of the art forward and actually increase adoption.
It's difficult to disagree with this. We need some level of diversity, but without interoperability, it's not very useful for something that is infrastructure driven, like confidential computing. Thank you very much. Ian, what do you think? Ian Oliver, you are on mute.
Coming back to me again. I think, as Greg pointed out, I mean, this is quite simple. This can be classed as an availability problem overall. Okay, different architectures, TDX, trust zone, CCA are all targeting different potential use cases, but CCA for low power and very much more distributed equipment, TDX for the data center. Some things have become easier, but yeah, we still have this problem of it being too heterogeneous. So if I write something now for CCA, it's not going to work anywhere else, and that could be a problem that's going to restrict me in other ways. As for the attestation part, how long do we have? I can talk hours on that one. That's my big problem. And I'll summarize that by saying, last time I was in a confidential computing conference last year, I stood up and said, look, forget all your technology. If you can't get me the data that I need to use to make an attestation, none of this means anything. And that's my problem.
Absolutely. And this was clearly everyone's problem so far at different stages. You are in and we mentioned earlier that there is also a deficit of combined skills necessary to implement but also improve something like attestation. What do you think could be done to create a difference there?
Hank is online. Standards, but
Yeah.
yeah, yeah. I mean, we don't have to standardize the actual, the data formats and so on about attestation, but we do need a standard way of getting it. And that way should give me consistent information each time. So if I attest a TDX object for some definition of object, or a TPM or a CCA enclave, or a container or a VM, I should get some information back. Um, it's understanding how all those then relate to each other. Um, what does it mean for a trusted VM to be running in a TDX environment? Can I cross-reference that with the platform that's running on, with information from the TPM and so on? It's understanding how all these fit together rather than data formats. I don't care whether it's JSON, YAML, XML, CBOR, whatever. It's irrelevant. But we do need some idea of what information I'm going to get back and how I cross-reference that, and actually how I use that over time to decide whether my system is still in a trusted state going forward.
Yeah, it's easier to say that than
It's
to do
easy to say
this,
that.
right? Having written a paper on virtual TPM first in, I think, 2006, I can tell you that you can conjecture about a lot of things. It's harder to make them real. Thank you very much for this point of view. I think we all share it. Ron, what do you think about confidential computing? You are sort of one of the fathers of the whole field. Where are we now? Where are we going?
I think I'm surprised at how far along we are on the technologies, right? It's been what, 20 years, much longer if you look at the underlying, some of the underlying technologies. So that's the good news, right? We have a lot of maturity there. A lot of good work has gone into the current situation that we have, the deployments that we have, the availability of the actual technologies. The disappointing piece, I think, is what everybody's hitting on, which is attestation, that we haven't done more around reasoning about attestation, collecting the information, standardizing on how we do that, right? Just the availability of it and processing of it. Given that, as you pointed out, Claire, trusted computing, really was kind of the initial piece of this, right? And that's going back 30 or more years now. So hopefully we'll make some progress on that. I think we all agree that that's where progress needs to be made, the most, right? And I'm hopeful that a lot of the AI technologies that we see coming on board and the ease of creating, these different solutions, right, based on AI, will help with some of that. And of course, reasoning about all this attestation information, right, is the accumulation of all this data. Is that a yes or a no in terms of the trustworthiness of my environment?
Yeah, that is certainly an excellent summary. And I agree that significant successes of both trusted computing and confidential computing are impossible to overlook. I now see that the organizations that resisted the trusted computing so vigorously in the first decade of this century now require TPM for multi-factor authentication. So that's where everything is usually going when the idea is good. It just gets gradually improved. You mentioned that the push for confidential computing could be given by its new use cases. For instance, the use cases in artificial intelligence. Certainly, when people talk about the prospects and potential growth of confidential computing, they talk about AI, they talk about finance, they talk about healthcare data. What do you think is or are the killer applications that will propel this technology in the next 2-3 years?
I think it has to be, and the thing that all those have in common, right, is the value of the data and the value of the processing on that data, the secrecy, the confidentiality of that capability, right, of those operations, right. So wherever there's high value data, high value computation, ideally that has to be done in an environment that you may not necessarily trust or you don't have direct control over. That's where the use cases will be, right, because it's really the money that talks, right? If there's real value associated with something, then you'll put something behind it, right? There'll be emphasis behind protecting that operation and that data.
Absolutely. And usually, the understanding of a value of certain data corresponds to the availability of significant resources to implement new technologies in that area. So for now, that particular area is artificial intelligence, and hopefully it will propel confidential computing as well. Thank you very much. Ian Kamenish, we have a question about data sovereignty. Do you think, the question says that it will lose most of its criticality if confidential computing is properly implemented and available from the public cloud? What do you think?
Yeah, I guess let me maybe before going into that question, because it's a related question to what Ron brought up in terms of how valuable data is and so forth, right? And so far we've been talking about the hardware level, right? How like where the hardware runs and sovereignty actually comes in there as well. And I guess where I'm trying to go here is more like the blockchain technology, right? Where in some sense it's a completely different approach. It's like some of it is entirely transparent, right? But if you talk about like valuable data, if you look at the Bitcoin network, how valuable that data is, like it's a lot of money there, and actually it has withstood the test of time quite beautifully because it takes like a different architectural approach, right? It's like a distributed protocol, and the trust, or I guess in the blockchain lingo, most people would call it trustless, but I guess that's maybe a bit of a misnomer here. Anyways, so you have this distributed protocol, and that distributed protocol actually provides you a secure system by maybe full transparency. It doesn't have to be full transparency, right? But like it provides you like the secure system. At the end of the day, that's what we need. And if we look in systems today, regardless of whether they're running inside a TE or not, right? Because like most like they can all be hacked. Cybercrime goes up, and actually also AI here enforces that. So in some sense, like data sovereignty is completely gone for most things, unless we manage to port, like our infrastructure into infrastructure that's built differently. And I believe that's the future. It's built from protocols like blockchains, and we see that going on as well, right? I mean, like of course, people now realize, well, Bitcoin has no confidentiality, it's secure but not confidential, right? People get mocked on the street because other people have found out how much Bitcoin they have, which is of course very bad, like on multiple levels, but also meaning that of course you cannot run confidential compute with that. But again, right? I mean, like, there's like other cryptographic technology there, and even TEs, right? I mean, like with attestation or some form of attestation. It doesn't have to be like a central attestation. It could also be, like people just say, well, we do that, or get audited. I mean, all this attestation topic will come in there as well, right? But there you can have confidential compute. You could do multi-party computation, full homomorphic encryption, where now people actually can run stuff that they could not have run just 5 years ago, right? So because we sort of converging in some sense from two areas, right? So from making hardware better, and hopefully one day we will have hardware where like the current keys, if somebody has physical access, they're not secure. On the other hand, if you run that, I don't know, in an Amazon data center, probably those attacks are ruled out, and Amazon says, sort of assures you that you have they run the right hardware, so you don't really require attestation. So I see that a lot of things are converging, and it's like a very exciting time to see how all of these things come together. And at the end of the, like coming back to your question about data sovereignty, right? And I mean, before I've been at the Dfinity Foundation, where we built like like an internet computer where you can just put your compute on the internet, again using blockchain technology, using TEs and so forth and so on. But now that's actually how you get sovereign compute, right? Because now sort of if your compute runs on the network, runs on a blockchain, however that's built, then actually you are again in control of your data. You don't provide your data to like third parties, Amazon, who then gives access to other parties. So I think the future is really like that, right? And protocols that do the compute run on hardened hardware, and that gives them back control to user, and you have data sovereignty that we had always wanted in the last 40 years.
Yeah, thank you. It certainly is true that we are a little closer now to the dream of user-controlled privacy and security than we were 25 years ago. It's still a long way to go, but what you outlined as a potential approach is certainly a great vision that many people, if not everyone, could share. Now continuing to talk about the influence of potential new and expansion of existing use cases on the propagation of confidential computing. Greg, what do you think is a potential killer use case for confidential computing? Is it AI? Is it blockchain, finance, something else?
To me, there's really two kind of killer apps, and I'm not sure a killer is the right word, quite frankly. I think that's yet to be seen. AI, while perhaps not the most deployed application today, I think has the most potential, primarily because it concentrates three high-value assets: proprietary models, sensitive training data, and confidential inference prompts and outputs. So we're combining three high-value assets and their processing all in one place, right? That's, adding to what Ron and Jan were saying, right? That increases the value, that increases the likelihood that someone will want to protect those assets. So confidential computing protects both the models during training and during inference, preventing unauthorized inspection of the sensitive prompts, and it enables secure multi-party collaboration in that sense. I'm encouraged to see the number of GPUs that NVIDIA has deployed already as products. There's the Hopper line, Blackwell, and there's some other product lines that they've already introduced as well. And those are, the fact that NVIDIA is investing and deploying products both in the GPU world as well as networking environments. There's the Bluefield 3 and 4, I believe, that also have confidential computing, even though they're not AI processing systems in and of themselves, right? Gives me a lot of confidence. I also think that having full virtual machine availability by cloud providers, perhaps without all of the attestation infrastructure, kind of as discussed a little earlier, just having guarantees from the provider about the protectedness of those virtual machines will give a number of implementers the confidence to go and implement there, even if they don't fully understand how their data is protected within the confidential computing environment. So I'm really hedging my bet here, but I think will be the primary vehicle, and full support in virtual machines and things like Kubernetes, et cetera, in those kinds of environments, perhaps with less of the infrastructure uplift of attestation, are the two areas where I imagine the most impact.
Thank you. This seems to be the general consensus that AI is going to be instrumental in fostering greater deployment and use beyond deployment of confidential computing. Hank, what do you think is the killer application for CC?
So as the agentic AI mesh already was mentioned, I think I want to say a typical placeholder for a lot of similar applications is the so-called payroll application. Internationally acting enterprises require those to interact between nations. There are sometimes hurdles, and the confidential computing has this killer feature, which is kind of a killer app, that the hosting operating system doesn't matter. It's the platform, it's the confidential workload, the hosting OS in between. You don't have to care about that anymore. That is not what it's talking with each other. So I guess payroll application obviously are one other thing, and there is this all the I want to say the value determines, as we initially said, and I think that was Greg. It's not worth the money. It's so expensive. Also, all the many things, and this could be better, right? But the value add here to protect the value is layering confidentiality and transparency. So you have confidential data, all the model stuff that was listed, like training data, model data, inference, especially behavior of AI, for example. Then you want to make that behavior, like all the conversations in between these confidential nodes, transparent in some scope, because you want to observe the agentic AI behavior mesh. It's basically a verifiable agent conversation record that you have to then verify again. That is, again, very confidential. There could be a lot of PII in there. There could be a lot of IPR in there. Like, how do I engineer this better? So that is not the thing you want to look at. So that's confidential again. And then you want to understand that the agentic AI mesh, the whole tree that blooms when you make agents call agents. That has to be the thing it is intended to do and nothing else. And that is, again, trustworthiness. And so checking that this is a layer problem. So there's a killer app here by making this sandwiches of confidentiality, transparency, and this really solves some interesting problems that will come up, especially when and this is true, you can look it up on the internet, I'm not quoting the source, but when your agent that is going to be to decommission tomorrow starts to blackmail the admin via email actively. So that's an interesting scheming. So I'm using a lot of buzzwords here right now, and obviously that's just a fringe case. But in all earnest, the behavior of the things that we have in these confidential things can't just be confidential by themselves. So it's another layer, and I think that's an interesting killer app where we will have to invest in how to, in a feasible way, because you are responsible for your confidential workload mesh, I want to say all these nodes, how to make that again trustworthy. Just because it's confidential doesn't mean it's doing the right thing. And also, you don't want to build the next dark web 2.0 where there's no more intercept anymore. And so there will be future challenges, but I think the killer app is on this next sandwich layer.
Thank you. We recently had a panel on AI security, and very similar thoughts were expressed there without specifically naming confidential computing. So it's clear that there are some very good, at least in theory, common, broadly applicable uses for confidential computing. What are, however, the challenges to implement and use confidential computing at a large scale? Ron, what do you think? What are the greatest challenges that we need to overcome?
I don't know about the greatest challenges, right? I think maybe it was Ian who touched on it earlier, the availability of the infrastructure, going back to mainly attestation, right? But just the capabilities themselves. Several people also pointed out the differences and how VM protections are implemented, right, between AMD, Intel, and some of the ARM vendors, right, which is still emerging there, right? And reasoning about those differences, right? How do we move workloads between different cloud vendors, right? When they add some of their own special sauce, right, around their deployments of confidential computing, right? Those are the real challenges. I think long-lived workloads, right? A lot of these AI-based use cases that we talked about are intended to run long-term. We're talking not days, not months, but maybe years, right? Over that time, those machines will need to be maintained, right? They'll need to be brought down. Those workloads will need to be migrated from platform to platform over time. This all impacts, right, the attestation information, the long-term trustworthiness, and how we reason about that. Those are all really big challenges, I think, right? And then you throw into the mix of that, not just the CPU differences, but now we have the different accelerators, right? It's great to see what NVIDIA is doing. I think they're still in the early stages of implementing confidential computing capabilities as well. It's slightly different than what we would think about in terms of a VM on a CPU. Other accelerators, right? Some of the DPUs, I think Greg mentioned, right? They also have very unique operations that they perform, right? In environments that don't necessarily map to virtual machines one-to-one, right? So that diversity of technologies, of hardware technologies, right, is also a challenge.
Thank you. Those are enormous challenges. You mentioned something that is not discussed frequently. What should be the approach to long-term attestation? The whole process was designed to be sort of instantaneous. We ask you to attest that a process is truly running within the confidential computing infrastructure, and you are saying yes or no. But in the modern applications, you need to do this continuously within the same attestation for a while. How can we address this?
Yeah, that's a huge challenge, right? You think about the amount of attestation information that will be generated in these environments. Do you take the workload back to some known good state, right? Or do you really want to preserve all that information of all the environments that workload or that data ever existed in, right? And now, if you can do that, is the trustworthiness of that workload and its data just the minimum level of trust that you ever had in any environment that it existed in? Probably that's how you have to look at it, right? So how do we take those workloads and that data back to some known good state and start over with a higher level of trust, hopefully?
Yeah, I think it's a huge issue. I think it's worthy of sort of government-funded large-scale research program, and hopefully it will happen one day. Thank you, Ron. Ian, Oliver, what do you think?
You're muted.
Wonderful technology. It's keeping me confidential. Yeah, I mean, Ron touched on something very interesting here, which is how do we migrate workload while preserving the security context? And as you well know, Claire, the difficulties of migrating virtual TPM, technologies like Intel PTT, we haven't solved that one yet. I mean, I do it quite nicely on an office setup, and I've got like 30, 40 VTPMs sitting out on a NAS somewhere, and it's not a nice situation. But also the amount of attestation information we're getting, this then plays into attestation over time, the trust context over time, and digital forensics. There is no research on this. Well, there is very little because some of my team have done it, but shout out to some of my former students there. But just looking at how we would use that information over time, and what does it mean to have all this information, all this, these slices of time encoded in attestation. How does that work over time? What does it mean? How do we compute the differences over that? What do the differences mean? And then you get into all sorts of very nice areas, such as what is the analytics over this? If you've discovered the trust context changing over time, or you're losing or degrading trust, for a start, what does that even mean? I don't think we, other than the sociological definition of the word trust, we don't have a very nice definition of computational trust. But if you do notice something, what do you do? What's the orchestration procedure in order to get trust back in a system? And these are huge open questions. So at the moment we talk about, we go and attest that, and that's at a point of time. If you gather this information over time, then you could see how your trust context changes. I don't really think we've got a good handle on what that means. We've done some small experiments on this, but I'm hoping to start now doing this with some TDX machines and bringing the supply chain to that. But the amount of data is enormous. And then, of course, there's the problem: where do you process this? Do I then bring up another enclave to go and process that attestation data? So, this is an open question. When we've solved the mobility of TPMs, then we can come back to this, I think.
Well,
Ron is laughing there.
A very fair summary of where this stands. Well, almost 20 years ago, we were trying to introduce the concept of trust evidence, sort of a canonical list of parameters that could constitute contextual trust evidence over time. And it was way ahead of its time. Maybe soon it will be time to revisit those ideas to see if they could be implemented in the more modern computing environment. Jan Kemenish, what are your views?
Yeah, I mean, let me just lower the hand here again. So, I think that there's two angles here, right? I mean, of course, I think like migrating is actually very easy in many ways, in the sense that if you have a replicated protocol, actually you could just like it has redundancy and so on and so forth. You could actually just shut down one of those machines, bring up another one, and it will sync up, right? And so now if this is like another TPM, whatnot, you don't have to move like your code and data from one TPM into another one and go through all this pain, because like you have a higher level compute protocol that will actually take care of this for you. So I think it's, again, maybe taking a step back and actually thinking about, okay, so what actually, how do the compute best, right? And second, at the end of the day, your trusted computing environment is just like one instance of like a plain computer, and whatever runs on top of that, I think we really have to change. And then again, the combinations actually makes things way easier, such as replacing machines, upgrading them, and all of that.
Thank you. That's a very good clarification. Since we started discussing it, what, in your opinion, are the most important challenges to the broad-scale introduction of confidential computing?
You're asking me again?
Yes.
Okay. Well, I think at the end of the day, any of this is really adoption, right? Because whatever it means, like there is existing systems running, and unless you do something like blockchain, invent something entirely new that maybe people use, maybe people don't use, it's really like porting the industry, existing solutions over to new systems, however they work, right? If they're inside new environments, if there's blockchain protocols or distributed systems, so getting that adoption done, I think is very hard. Again, it's maybe the killer use cases, maybe it's like the financial industry where people see that the existing systems are not really cutting it either because they're too slow, right? I mean, if you want to, and I guess, Hank, you had mentioned that international payments for salaries, right? It's a huge pain because something that takes days, and it's just where also people try to use Bitcoins now because it's faster. So you see the banking industry going there, but of course there you need confidentiality. You can't have these things open. I think that's a way in. And at the end of the day, also AI can really help here, right? Because before you had to adopt, translate, but I think AI is really good at taking some code, rewriting it into other code. Of course, there's some security issues there as well, but it's really accelerating that, right? And so I am much more confident now that we can migrate today's system onto new platforms that are more secure just with the help of AI. But I think the challenge is really getting people to migrate, getting people to trust new technology. But I think we're in good shape, much better than we were like 5 years ago.
Thank you. I completely agree with this. Let's now move to discussing on how you view the immediate future and prospects of confidential computing. What do you think will happen in the next 2-3 years? Market research analysts predict significant growth to confidential computing without details, like up to 75% growth in the next 2-3 years, and even more significant growth in the next 10. What do you think is the reality? Where do you see the confidential computing near term, like 2-3 years from now, in terms of deployment, in terms of resolving technology challenges, in terms of adoption, and so on? Greg, what do you think?
Because confidential computing unlocks new capabilities and services beyond risk mitigation, such as secure collaboration, confidential AI marketplaces. There's all kinds of concepts and services that could arise. There are drivers of success that exist beyond those of traditional security products and services. That's a really good thing. I don't believe the technology will become universal in the short term. Certainly, it may become indispensable environments where the economic value of the protected assets justifies its operational complexity. I think we've all mentioned quite a few challenges to the technology, and without overcoming the attestation questions and interoperability and things of that nature, it's hard to imagine broad adoption. But I can't going back to the use cases discussed earlier. I still think there's huge opportunity for advancement in AI and in virtual machines. And kind of in my mind, I gauge the success in tangible ways. If we see price competitiveness of confidential computing virtual machines with standard VMs, if we see clusters marked as secure by default without users having to deal with attestation, just trusting the cloud vendors, if we see AI procurements that require confidential computing, and if we see AI models that advertise hardware-backed product, hardware secured products, those will be markers of success going forward.
Thank you. So you are cautiously optimistic, but also very cautious.
Indeed, I'm cautiously optimistic.
And you don't think it will become?
I beg your pardon?
No, I said that you expressed a very measured view. There are some possibilities for significant growth, but not for universal adoption near term. And I agree with this. Thank you very much. Henk, what are your views on the immediate prospects? Where do we stand?
Okay, as to save some time, I have to live up to my infamous rep as terminology nitpicker on standardization. So all these types of evidence from the platform and from the, I want to say, enlightened workload. So a workload that knows it has to be an attester and has to give you evidence to, which is one type of attestation, the one half. Then there's this attestation service, which you typically call verifier, then it can now be co-located because it's also isolated. That's nice, kind of. So you have a little more flexibility with hybrid clouds. Is it on your side? Is it on their side? That's nice. But what really important is when all these inputs to the verifier, and it's not only evidence from platform and workload that is confidential, but also all the other parts, the endorsements from the vendor and the reference values from vendors or from your own, because it's your own software running, and the policies that check them. There must be deterministic verifier behavior. If you change the verifier and have all the same inputs, you can't have a different result. And that is real interoperability and standardization. If that doesn't work, it is all like a little bit, everybody has their own thing. And then, of course, you can have the attestation result as the output. And if it will look like similar, even if the output is kind of not the same, that is at least something. So we have orderly attestation results for the relying party. That's fine. But I really want to stress that you have to separate these attestation services that verifies. I think that's a prospect for the future, because Intel might be the best to endorse and then have a verifier for the appraisal of evidence of Intel components. And my workload comes from off the shelf some X. Yeah? So maybe it's a distributed verifier system, and I don't have to do it all myself. And that is offloading some of the complexity, and now it's getting better. So I think that's a future prospect and challenge to change. So, but I think the deterministic verifier behavior and also the fact that you will have more than one verifier, I think, are the things that will happen very, very close term and are done today by companies. I will not name any specific ones, but they are out there, and they're already passed through. Like, you get a bundle of different components, and one of them is the earliest trusted, and they have partnerships, but that's more of a lock-in system. We want to have this very flexible, and that's the real prospect to win.
Thank you. So you are talking about improving the balance between attestation and the necessary verifiers, and that will bring us towards potential broader adoption. A very good point. Thank you very much. Jan Kemenish, what do you think?
I guess I sort of hinted on that already before, right? I do think that now the world has understood that, like, traditional IT systems need to be replaced long term, or well, I think rather short term, and we see institutions experimenting with this kind of technology. So again, I think I'm very optimistic that we will be able to replace, like, get some trusted compute space out there. I agree, like, this whole attestation thing. I remember, like, the first time we talked about, I guess, when I was working with, was like 2003 or something, right? And
Yes.
but I think, again, we need a combination of those two things and both seeing them. And I remember, like, 2004, it was like Microsoft announced that they will actually shelve their plans of a test to the whole Microsoft operating system. And that's why I was bringing up the blockchain back in, where I think, yes, you need to have, like, that compute layer needs to be replaced with something that's actually manageable, that's not like a continuous, like, evolution, but rather we need the revolution here. But on the other hand, like TEs, and so we need to have them too, because otherwise you cannot build, like, a trustworthy system either. But I think both these things are happening. There's also approaches, like different approaches, where people put whole boxes into compartments. Again, attestation comes in there too. But again, I think it is exciting times, and we will see a lot of change happening here. And I think adoption with AI will also speed up quite a bit. So I'm glad how things are accelerating, and much more optimistic than I was just a few years ago.
Thank you again. I agree. It's an exciting time, and it's a good time to be at least cautiously and perhaps more optimistic. Thank you. Ian Oliver, what do you think?
I'll successfully come off mute this time. A few things have come up here. What I'm most excited about now is this idea that we'll be able to ideally ship a box, a black box, and whatever I put into that will be processed confidentially. So if you like, it's confidential compute as a service. Yeah, maybe terrible. I could have patent sort of trademark that term now anyway. I tell you what, the most exciting thing that I think is going to happen over the next year is ARM CCA becoming much more widely available. And the primary reason of that is because we are seeing this push to have small data centers on the edge of the telco network. And if you've got confidential compute capability there from the start, and CCA is, or we hope it's going to be this very nice VM-based approach. It's going to be easy to program for. It's going to be easy to test. If you have that in a box already, it's going to be very, very easy to write APIs for that, front-end services for that. If we can get that working, that's where we're going to see some very, very interesting use cases coming up. So that's the thing I'm most looking for at this moment in time. We can bury attestation inside, that's fine, or we can have some very lightweight attestation coming out. But if we have that, I think that's going to be that's going to make a huge difference to the uptake of this. And being able to sell a product, confidential compute by design, there you are, done. Push your encrypted data in, don't worry about anything. Brilliant.
Thank you. We have a new expression, confidential computing by design, that probably will be used.
That one
that probably will be used by other people before too long, and the age certainly is an extremely rich use case that is frequently overlooked. Thank you very much. And Ron, you have to have the last word about the prospects of confidential computing near term. What do you think?
Well, I would have hoped we've been farther along than we are, right? But I am very excited about the future. I think this nexus that we're at, where AI is driving huge deployments, right? Huge investments in infrastructure at a time when we're also concerned about, the value of the data that's being processed by AI, right? Whether it's training data or the resulting data, the prompts, et cetera, right? The models themselves, right? There's a lot of value there, right? These are all coming together at a time that is really good when, as we discussed before, the actual underlying technologies around confidential computing are at a maturity level where it does work, right? For the most part, it does work. There's a lot of challenges that we discussed, right? But pretty much it's useful, it works, right? So we're going to see in the cloud environments, right? A lot of usage, even if it's a small percentage of the overall use cases, the rate that we're growing because of the AI push, right, is going to mean that there's a lot of workloads that are using confidential computing. The CCA, the ARM piece, right, is going to be interesting. We haven't seen a lot of use yet around confidential computing in industrial environments, embedded environments, right? So, these edge servers are a good example of that, right? I think once we see ARM deployments really start to accelerate, right, in those environments, in automobiles, et cetera, right? Those are a whole new set of use cases, right, for confidential computing. So I'm excited. Hopefully I'm not wrong this time.
I hope not either. So we conclude this panel on an optimistic note. Everyone agrees it's an exciting time. There are promising use cases. Hopefully, the adoption will follow based on available faster than it did for trusted. Thank you very much, our distinguished panelists, for participating. Jan Oliver, Jan Kemenish, Henk, Greg, Ron, thank you so much. It's a huge topic. We were only able to scratch the surface with basic questions today. hopefully we will be able to reconvene in a couple of months to discuss some areas in depth. For now, thank you so much. It was food for thought for those listening in, and I am sure for our asynchronous listeners. Thank you. And thanks to TDL for hosting this panel. I now pass it to David. You want to say something, Jan? No?
Just to echo.
I now pass it to David to close.
That's goodbye.
Yeah, thank you, Claire, and thank you all the panelists. I echo what Claire is saying. It's good to finish on a positive note, and it's a big subject. It would be great if we can come back in a few months and revisit. So thank you again. The recording will be available sometime early next week, as will be the anonymous short report. So with that, thank you, and thank you to our audience for sticking with us, and look forward to seeing you again.